Hello, my name is Mohammed Fulwala, and this is my final project for EECS 2021 Computer Organization led by Dr. James Smith. The project I have right here is an external computer fan, or it's supposed to act like one. This device is basically a miniature fan that provides circulation of air if the surrounding air temperature around a computer increases. Now you might be wondering, why will that happen and why do we care? Nowadays, in order to make a computer slim or slimmer, computer manufacturing companies position the computer fan in the weirdest places like the back of a computer. This results in hot air being trapped around the computer, and consequently, the air temperature around the computer increases. When that happens, certain parts of the computer becomes hot to touch. Now, there is a rule of thumb that says if the temperature of a device increases by 10 degrees, the lifespan of that device decreases by 6 months. Now, that's not a good thing if you want your device to live longer. So, in my opinion, this is why we need a design like this. Now, the way it works is that we have a hobby motor connected to a pin of port C. Now, when we do that and we run a program that turns that bit on, we supply 5 voltage to that pin which powers up the hobby motor, and then it's connected to ground to complete the circuit. We have used the same concept for these LEDs as well. The 4 red LEDs are connected to port D of the Atmega 328 microcontroller, and the 5 blue LEDs are connected to port B of the Atmega 328BB microcontroller. I have also connected 10 kilo ohm resistors in series with the LED so they don't die out. Now the way I've designed this is everything, all of this is connected with this button over here. So what I'm saying is if I press this button, then the motor should turn on and the LED should turn on. The LEDs are basically just a test to see if the button is working or not. In this design, I would use a switch, but since I don't have that, I'm gonna have to make do with a button. So when I run the program, there we go. And when I press the button, the LED turns on, but something weird happens. The motor is not turning on. This is because there is an interference that does not turn the motor on. It doesn't give the jump start voltage it needs. So basically, if I just press the button and I move the motor a little bit, it should turn on. As you can see over here. So this is proof that my device works. Okay, so here's how the program works. Over here, I'm turning on certain pins of port B to output. Over here, I'm turning on one specific pin, that is pin 7 to input, because that is the button. That's where I want the input. That's where I want to check if the button is pressed or not. This, I'm turning one bit on for port C to be output, and I'm turning a couple of bits on for port D to be output. Now, this process, as you see all over here, from here all the way down to the end, is basically me setting a timer mode to CTC, and I'm setting up an interrupt service request for that timer. So basically, after an operation, if the timer counts up to this value over here, 0xFF, then it will call the interrupt service routine. and it will execute the statements over here. Now, the main thing about this project is this button test. So if we go to that method over there, we are putting this in an infinite loop, by the way, and we are checking if the button is pressed. This statement over here means it checks if the button is pressed. If that's the case, then it turns the LED on and turns the fan on. For this, nothing much has happened. All I've done is I've just turned on certain ports, and this will provide the voltage to the certain pins, these pins. Else, if the button is not pressed, then I'm going to turn the LEDs off and the fan off.